question here, combine like terms. So let's see how we will do this. Question 1, 9x minus 4x. Okay, here what we will do, we will take the like terms. What's mean of like terms? Like terms is the variable is same in power and same of the letter. So x to x power 1 and x power 1. So the variable is same. What we will do, we will add or subtract together. We have 9x and negative 4. So 9 minus 4 will equals 9 minus 4 equals 5x. Excellent. Let's go next. 2z plus 5 plus 3z. So where is the like terms here? The like terms is z and z. This is the like terms, z and z. Okay, so let's combine them together or add them together or subtract them together. What is the sign for 2 and sign for 3? The coefficient here, where is the sign? The sign for the 2 is positive and the sign for 3 is positive. So 2 plus 3 equals 5. So 5z. And the 5 here alone, this 5 alone, there is any like terms same of the 5? No. So 5 will come 5 and we will have 5z. Okay, let's go next. Question 3. 6f plus 3 minus 4f plus 5 plus 10f. Where is the like terms? We have this one, take it with the sign, and this one. These three are like terms. We have 6f, negative 4f, and the plus 10f, or positive 10f. So let's combine them together. We will take them and combine. We will combine them together. Okay, so we will have 6 negative 4 will be 2. 2 plus 10, it will be 12f. Okay, and now let's take the other terms. We have 3 and 5. Are 3 and 5 like terms or not like terms or unlike terms? It's like terms. Why? Because both of them are number coefficient without variable, or the variable here is power 0. If the variable power 0, so it equals 1. So here we have 3 and 5, they are like terms. So we will take 3 and 5 together, add them, 3 plus 5, 8. So the answer here will be 12f plus 8. Let's see next one. We have here 9g and 8g. They are same variable or not? Like terms or not like terms? Like terms mean they are same variable. They are like terms. So 9g and 8g, they are same. So let's add or subtract to them. Let's add or subtract both of them. What is the sign here? Positive. And what is the sign here? Positive. So it will be adding. 9 plus 8 will equals 17g. Let's go next. Question 5. What is the like terms? The like terms here is 7b and negative b. Okay, 7 here is positive, b here is negative. What we will do? We will 7 minus 1. Why 1? Because here the coefficient for the p, this p, the coefficient of the p here is 1, but it's a hidden one. We don't write the 1. Okay, so it will be 7 minus 1 will be 6p. And we have negative 9. It will be same because no other like terms same to the 9. So it will be 9. So it will be here. The result will be 6p negative 9. Let's see our next question. Question 6. 3x plus 5 negative x plus 3 plus 4x. What we will do? First, we will take the like terms together. We have 4x, take it with the sign, negative x, and 3x. Okay, so combine them. 3 minus 1, we said 1, it's not written, so 3 minus 1 equals 2, plus 4, it will be 6x. So this 3 will give you 6x. How about the other terms? We have 5 and we have 3. 5 and 3, here the 5 is positive and 3 is positive. 5 and 3 is 8. So it will be 6x plus 8. Okay, let's go next. Question 7. We will do the same. Combine or identify the like terms. Where is the like terms here? We have 6x and negative x. This will be 5x. We have 4y and 4y. 4y plus 4y will be 8y. So here the answer will be 5x plus 8y. Go next. We have 4x and we have 3x. 4 plus 3 is 7. And we have positive 5, negative 1, y. Positive 5 and negative 1, y. So it will be 5 minus 1 will be 4y. So it will be 7x and 4y. Question 9. We have 5x and 4x. This 9x. Okay. We have 3y and negative 2y. 3 minus 2, 1. What is the result now? It will be 9x and 1y means y without, we don't write the 1. Here we don't write 1. Question 10. 6p plus 3p plus 7z negative 3z. So we will take p together, 6p and 3p. Both of them are positive, so it will be adding 6 plus 3, 9p. And for the z, we have 7z and negative 3z. Positive 7, negative 3. So it will be minus, different sign means minus, 7 minus 3. This equals 4z. Question 11. 7g plus 5h negative 12. Do we have any like terms here? Do we have like terms? We have another g, we have another h? No, so it will be same. 3h plus 5m plus 7h negative 4m. We will take the variable h together. 3 and 7 is 10. And we will take the variable m together. Positive 4 and negative 4. So 4 minus 4, it's 0. So the result here will be 3 plus 7h. It's mean 10h. Before we start solving or simplifying from question 13 to 15, please go watch this video and come back to me.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to talk about the distributive property, which is a really useful tool in algebra. And if you watched our video called the distributive property in arithmetic, then you already know the basics of how the distributive property works. The key idea is that the distributive property allows you to take a factor and distribute it to each member of a group of things that are being added or subtracted. Instead of multiplying the factor by the entire group as a whole, you can distribute it to be multiplied by each member of the group individually. And in that previous video, we saw how you can take a problem like 3 times the group, 4 plus 6, and simplify it 2 different ways. You could either simplify what was in the group first, or you could use the distributive property to distribute a copy of the factor 3 to each member of the group. And no matter which way you go, you get the same answer. But in algebra, things are a little more complicated because we aren't just working with known numbers. Algebra involves unknown values and variables, right? So in algebra, you might have an expression like this: 3 times the group x plus 6. In this expression, we don't know what value x is. It could be 4, like in the last expression, but it doesn't have to be. It could be any number at all. And since we don't know what it is, that means we can't simplify the group first in this case. Our only option here is to either leave the expression just like it is and not simplify it at all, or to use the distributive property to eliminate the group. Just like in the arithmetic video, we can distribute a copy of the 3 times to each member of the group, so the group goes away and we end up with 3 times x plus 3 times 6. The 3 times x can't be simplified any further because we still don't know what x is. But we can simplify 3 times 6 and just write 18. So the distributed form of this expression is 3x plus 18. And even though we can't simplify these expressions all the way down to a single numeric answer without knowing the value of x, we do know that these two forms of the expression are equivalent because they follow the distributive property. So the distributive property works exactly the same way whether you're working with numbers or variables. In fact, in algebra, you'll often see the distributive property shown like this. A times the group b plus c equals ab plus ac. Or you might see it with different letters like x, y, and z, but the pattern will be the same. This pattern is just telling you that these two forms are equivalent. In the first form, the factor a is being multiplied by the entire group. But in the second form, the factor a has been distributed, so it's being multiplied by each member of the group individually. And if you're looking at this thinking, what multiplication? Remember that multiplication is the default operation, which is why we don't have to show it in this pattern. Since the a is right next to the group, it means that it's being multiplied by the group. And on the other side, since the copies of the a are right next to the b and c, it means they're being multiplied also. And even though this pattern is usually shown with addition in the group, remember that it also works for subtraction, since subtraction is the same as negative addition. But the distributive property does not apply to group members that are being multiplied or divided. Okay, so this is the basic pattern of the distributive property. It's usually just shown with 2 members in the group, but remember that it works for groups of any size. We could have a times the group b plus c plus d, and the equivalent distributed form would be ab plus ac plus ad. Here's a few quick examples that have a combination of numbers and variables to help you see the patterns of the distributive property. 2 times the group x plus y plus z can be changed into the distributed form 2x plus 2y plus 2z. 10 times the group a minus b plus 4 can be changed into the distributed form 10a minus 10b plus 10 times 4, which is 40. And a times the group x minus y plus 2 can be changed into the distributed form ax minus ay plus a2, or 2a, which is more proper. So whether you're dealing with numbers or variables or both, the key concept is that the factor outside the group gets distributed to each term in the group. Each term in the group? But I thought terms were parts of polynomials. I thought we were way past all that by now. I was hoping you would notice that. And in fact, the members of these groups really are just simple terms in a polynomial. Well, that's what I'm here for, noticing things. Oh, a butterfly! Realizing that these groups of things being added or subtracted are really just polynomials will help you see why the distributive property is so useful in algebra. For example, in this simple expression, 2 times the group x plus y, the x and the y are simple terms in the polynomial x plus y. Each of the terms has a variable part, but no number part. And if we apply the distributive property to the group, we get the equivalent form 2x plus 2y. But what if the polynomial was just a little bit more complicated, like this? 2 times the group 3x plus 5y. In this expression, each of the terms in the polynomial does have a number part that is being multiplied by the variable part. But we can still use the distributive property to distribute a copy of the factor 2 to each term in the polynomial. Wait just a second here. I noticed earlier that you said that the distributive property does not work with members of a group that are being multiplied. And I also noticed that these terms do have multiplication. What's up with that? That's a good question. And it can be a little confusing to see how it all works at first. But notice that even though the terms do have multiplication in them, the terms themselves are being added. So we distribute a copy of the factor 2 to each whole term, but not to each part of a term. In other words, we treat each term in a polynomial as an individual member of the group, even if that term has multiplication going on inside of it, which is common since there's often a variable part and a number part being multiplied together. Getting back to our example, Distributing the factor 2 to each term gives us 2 times 3x plus 2 times 5y. But this can be simplified even further because we know that 2 times 3 is just 6 and 2 times 5 is just 10. So the distributed form is 6x plus 10y. Let's try another example of a factor times a polynomial. 4 times the group x squared plus 3x minus 5. First, we need to identify the terms of this polynomial, so when we distribute the factor, we just make one copy of it for each term. This polynomial has 3 terms, x squared, positive 3x, and negative 5. So we distribute a copy of the factor 4 to each term, and we get 4 times x squared, or just 4x squared, 4 times 3x, which is 12x, since 4 times 3 is 12, and 4 times the negative 5, which is negative 20. So the equivalent distributive form is 4x squared plus 12x minus 20. Let's see another example. X times the group x squared minus 8x plus 2. In this expression, the factor being multiplied by the group is actually a variable, but the distributive property works exactly the same way. And it says that we can distribute that factor and multiply it by each term of the group individually. The first term is x squared, which is the same as x times x. So if we multiply that by x, we'll get x cubed, since that would be 3 x's multiplied together. The next term is negative 8x. So if we multiply that by x, we'll have negative 8 times x, which is the same as negative 8x squared. Last of all, we have the term positive 2, and x times positive 2 is just 2x. So after distributing the factor x to each member of the original group, we have the polynomial x cubed minus 8x squared plus 2x.
After watching the video, let's solve our questions. Next question, question 13. What we will do here, 4 multiplies r plus 3 and then negative 3r. What's mean of this practice? This means that we will use the distributive property. How we will use it? We will take 4 and distribute it inside the brackets. We will take 4 and distribute it inside the brackets. So we will take 4 multiply 3 and 4 multiplies r. So we will have 4 multiplies 3 and 4 multiplies r, and negative 3r, it's same. Okay, 4r, 4 multiplies r mean 4r, 4 multiplies 3 equals 12. So we will have 4r plus 12 negative 3r. Now we need to combine the like terms. We have 4r and negative 4r. This means 1r plus 12 will be same. Question 14. Same. We will take 7 and distribute it inside the bracket. 7 multiplies x and 7 multiplies 3. So we will have 7 multiplies 3 plus 7 multiplies x plus 2x. 7 multiplies 3 is 21. And 7 multiplies x, it's 7x plus 2x. Now we need to take the like terms and combine together. Where is the like terms? Is 7x and 2x. This will equals 9x. So 21 plus 9x. The other parts from the questions here, from 16 to 18, we need to solve each equation. We need to solve each equation. Okay, let's solve. 6n minus 4n equals 68. What we will do here, we will combine the like terms. Where is the like terms? 6n and negative 4n. They are like terms, okay? 6 minus 2 is 2. So 2n equals 68. Now, what is the relation between 2 and n? What is the relation between 2 and n? It's multiplies. So, to undo it, what we will do? We will divide. Divide 2 both sides. What I will do here, I should do it in the other side. So 2 divided 2 is 1. And 68 divided 2 will equal 34. So n equals 34. Question 17. Y plus 5y equals 90. We will take the like terms. Here y and y are like terms. The first y, the sign here, the coefficient here is 1. 1 plus 5 is 6. Y equals 90. Now, what is the relation between 6 and y? It's multiply. So what we will do, we will divide x in both, divide 6 in both sides. 6 divided 6 is 1, so y equals 90 divided 6 will be 15. At the end of solving our exercise, after solving our book, please go for your book, page 586, and solve your homework. Thank you.